For this example, we're checking the convergence of this series. So I'm going to do this with the ratio test, which means that I'm going to take the limit as n approaches infinity of the n plus 1th term over the nth term. Now I am going to put absolute value on this. The ratio test has an absolute value, which means this negative 1 to the n isn't going to affect anything. Negative 1, the absolute value of negative 1 is 1, and the absolute value of positive 1 is 1. So I'm going to ignore that and write x to the 2 times n plus 1. What I'm doing is replacing the n with n plus 1, not just adding a plus 1 to get the n plus 1th term. So my denominator will be 2 times n plus 1 factorial. And this is the n plus 1th term over the nth term, which is x to the 2n, over 2n plus 1 factorial, and we're taking the absolute value of all of this. We know that this series will converge by the ratio test when this is less than 1. So now we just have some simplifying to do. So when we divide by a fraction, we multiply by the reciprocal, so I'm going to do that, and that means that the limit as n approaches infinity will be of x, and I'm going to simplify a little bit. 2 times n plus 1 is 2n plus 2. That will be in my numerator. This will stay in my denominator. When I distribute this 2, I have 2n plus 2, then I'll add 1, so this is 2n plus 3 factorial. I'm multiplying by the reciprocal, so I have a 2n plus 1 factorial in the numerator. And then I have x to the 2n in the denominator. And I'm looking for when the absolute value of that is less than 1. So the next step is actually to simplify the fraction. So this will be the limit as n approaches infinity, and let's take the x's first. It's x to the 2n plus 2 divided by x to the 2n. So there are 2 more x's in the numerator than in the denominator, so that leaves me with an x squared in the numerator. If I look at my factorials, 2n plus 3 factorial is bigger than 2n plus 1 factorial. So I'm going to start by writing 2n plus 3 factorial and stop as soon as I get to 2n plus 1, because that's when all the terms start canceling out. So I know this will be 2n plus 3 times 2n plus 2. When you do a factorial, you subtract 1 from each term. The next term would be 2n plus 1, but that'll start canceling out with the 2n plus 1 factorial, so I stop. I have absolute value is less than 1. The next step is actually to look at this and decide what is not being affected by the limit. So the limit is as n approaches infinity and not about the x's. So I can take this x squared and pull it outside. Normally, I would have to keep the absolute value on what I pull out, but x squared is always positive, so I do not need the absolute value. So this will be equal to x squared times the limit as n approaches infinity, and I don't need the absolute value on what's left either, because n is going from 0 to infinity, which means these are actually always positive. If it was 0, it's 3 times 2 is 6, and then n is only getting bigger, so I will have a 1 over 2n plus 3 times 2n plus 2, and I want to see when this is less than 1. So your next step is actually to evaluate this limit. Well, this is a 1 divided by something really huge, because the denominator would be an infinity times an infinity, so it's quite large, so we know that this is going to 0. So the question is, for which x values is x squared times 0 less than 1? And we know that anything times 0 is 0. So the answer is for all x values. So this converges on the interval from negative infinity to infinity. That problem is finished. This series matches the function exactly.